Ready. Good evening. I welcome you all on behalf of ACE Online and ACE Academy to GATE 2026 Score Booster Series. This series is particularly for helping you solve NAT and MSQ questions, because in the recent past we have had these questions coming. Okay, and these questions will be coming in this GATE examination also. So let us get started. I'll start with a relatively simple question first of all. Let me step aside. The question is saying over here, for the collar shown, the resultant of three forces shown is to be vertical. So he has given a condition over here. The resultant of three forces over here is vertical. I'm sorry, there was a power issue. Let us continue. The question is saying, for the collar shown, the resultant of three forces shown is to be vertical. So you're having three forces acting over here. This is 200 Newton, this is 150 Newton and 100 Newton over here. The resultant is supposed to be vertical. Okay. The required value of alpha, this is supposed to be alpha. The required value of alpha is equal to how much is being asked. The magnitude of resultant is equal to how much is being asked. So you see over here, there are two options corresponding to the value of alpha. Any one of them may be correct. There are two options corresponding to the value of resultant. Any one of them may be correct. Let us see how do we solve this question. I'm starting with this data given. Summation net force is supposed to be vertical. If net force is supposed to be vertical, then I can say sigma fx over here has to be equal to 0. Sigma fx has to be equal to 0. Now what is sigma fx over here? If you see, the positive x direction components are 100 cos alpha plus 150 cos 30 plus alpha. So I have over here 100 cos alpha plus 150 cos of 30 plus alpha. The negative side component is equal to how much? It is equal to 200 cos alpha. It is equal to 200 cos alpha. Now what I can do is, I can take over here this 100 cos alpha to the other side. I get 150 cos 30 plus alpha is equal to 100 cos alpha, divide by 50 also. So I'm going to get over here 3 times. I'm going to get over here 3 times cos of 30 plus alpha has to be equal to 2 times cos of alpha. If I divide by 30 also, 50 over here. Now what is cos of a plus b? It is equal to cos a cos b minus sin a sin b. So from here I can say 3 times cos 30 cos alpha minus sin 30 sin alpha has to be equal to how much? It has to be equal to 2 cos of alpha. This is what I'm having. Let us do one thing, simplify this thing. Let us say we divide throughout by cos alpha. If I divide throughout by cos alpha. If I divide throughout by cos alpha, this equation over here is going to become 3 times cos 30 minus 3 times sin 30 tan alpha. So I'm having over here 3 times cos 30 is equal to root 3 by 2 minus 3 times sin 30 is equal to 1 by 2. Excuse me. Into tan alpha is equal to 2 over here. This is the value I'm having. So now you see the value of, if you simplify this, you will get the value of alpha. You can multiply by 2 throughout, push it over here. You are seeing 3 tan alpha is equal to 3 root 3 minus 4. So tan alpha is equal to 3 root 3 minus 4 divided by 3, which implies alpha is equal to tan inverse of this value. So I can do the calculation over here, tan inverse of I'm getting the answer as 21.738. So if I want to round off to 2 decimal places, I'll get 21.74 degrees. So if you compare over here with the options, let us see, do we have any option? 21.74, 21.73, approximately both of them are same. So you can tolerate that much of difference. One option over here is option A. Next, we have to identify the magnitude of resultant. The resultant over here is basically vertical force. So I can calculate the resultant as summation of Fy. Summation of Fy is equal to resultant over here. If you recall, the forces were something like this. There were 3 forces. This was 200, excuse my handwriting, this was 150 I believe, and this was 100. This over here was 30 degrees. I'm not drawing to scale. This is the alpha value 21.74, and this again is alpha value 21.74 degrees. Now the value of sigma Fy over here is equal to, now all of them are in vertically downward direction, so I'm forgetting about the sign convention over here. It is equal to 200 sine 21.74 plus 100 sine 21.74, which gives me 300 sine 21.74 plus 150 sine 150 sine. If you see, the net angle over here with respect to horizontal is 51.74. 51.74. If I calculate this thing, I'm going to have over here 300 sine 21.74 plus 150 sine 51.74. This value is coming out to be 228.9 Newton. This is equal to 228.9 Newton. Let us check, do we have any answer, any option supporting this 228.9? So you see over here 228.83 is very close to 228.9. That much error can be tolerated. So the answers over here are option A and option C. Okay. Now this question was based on the first topic, which is the concept of forces, system of forces and moments. Okay. Next question I'm taking over here. Now this question is particularly for mechanical department only. In between I'll be taking civil and mechanical both questions. This is particularly for mechanical department. This is from the concept of impulse momentum equation. The question is saying a ball of mass 3 kg moving with a velocity of 4 meters per second undergoes a perfectly elastic direct central impact. Perfectly elastic direct central impact with a stationary ball of mass m. After the impact is over, the kinetic energy of 3 kg ball is equal to 6 joule. He has not mentioned the direction sense because he is only mentioning kinetic energy, scalar quantity. So therefore, he is not worried about the direction sense over here. The possible values of m is or are. Now there are multiple possible values of m, let us say. Actually 2 possible values only, depending on whether the vector is in forward direction or backward direction. So therefore 2 values will be there. So we have to identify the possible values over here. Now most important point to note over here is we are having perfectly elastic direct central impact. Now what can you say regarding perfectly elastic direct central impact? The coefficient of restitution is equal to 1. Therefore there is no loss of energy for any kind of deformation. So kinetic energy is conserved. Coefficient of restriction is also equal to 1. Anyway, I'm going to start over here with the kinetic energy of the ball, the 3 kg ball. After impact is over, the kinetic energy of 3 kg ball is 6 joule. So now I can say this is 3 kg ball. This is mass is m over here. Initial velocity u over here is equal to, let us say, 4 meter per second. This initial velocity over here is equal to 0. Okay. Now, by the virtue of this impact, his velocity will guarantee be in this direction. V2 will be in this direction. I do not know the value of V2. I don't know its value. But guarantee it is in that direction only. It is impossible for V2 to be in the backward direction. Now, he can either be in forward direction, let us say this is A bit, or he may be in backward direction after impact, let us say this is B bit. There are 2 possibilities over here. That is why I'm saying there are 2 possible answers for M also over here. Now, I know the value of kinetic energy after impact is equal to 6 joule for him. So I can say kinetic energy for 3 kg ball in stage 2 is equal to half of 3 kg into V square, V1 square. This is equal to 6. If you equate this to 6, let us say I don't have sufficient space. If you equate this to 6, you get 3V square is equal to 12. So V1 square over here is equal to how much? V1 square is equal to 2 meter per second. So A bit is you are having 2 meter per second over here. B bit is you are having 2 meter per second over here. I hope you're following till here. This I hope is clear to all of you. Please excuse my handwriting. I have taken some good questions, so I'll not be in a position to take care about my handwriting today. Okay. Now, if let us say I'm having this particular setup, A bit, let us solve for A bit first of all. If I solve for A bit, if the initial velocity is 4, initial velocity over here is 0, that means the relative velocity of approach over here is equal to 4 meter per second positive. Now, in such a case, the relative velocity after impact also should be equal to how much? 4 meter per second only. So therefore, if this velocity is 2 over here, this velocity over here in A bit is supposed to be equal to 6. B bit, coming to B bit. If the velocity over here is 2 this way, okay, if the velocity over here is 2 this way, for maintaining the relative velocity to be again 4, he should move over here forward with equal to 2 meter per second only, because positive 2 minus negative 2 will be equal to minus negative 2, minus of minus is plus. So 2 minus of minus 2 will again give me how much? 4. So the velocities possible over here are 6 meter per second and this is 2 meter per second. I hope you are following till here. Now what I'm going to do, I'm going for law of conservation of momentum. By law of conservation of momentum, I can say initial momentum must be equal to final momentum. Bear in mind, momentum is a vector quantity. Initial momentum of the system is equal to 3 times 4, 12 units, positive x. 12 units, positive x has to be equal to. Final momentum over here is equal to how much? Final momentum over here is equal to 3 times 2 positive, that is equal to 6 plus mass m multiplied to the velocity in A bit is equal to 6 positive. So you see 6 goes over here. I'm going to have 6 is equal to m times 6. M in case A is equal to how much? It is equal to 1 kg. So first possible value of mass is 1 kg. B bit, let us say, initial momentum is again equal to 12 units positive. Final momentum, this is moving in the backward direction, therefore it is going to be equal to minus 6 is equal to mass times 2, sorry, plus plus mass times 2 over here. You see, initial momentum of the system was equal to how much? 12 is equal to, this ball is moving backward, therefore minus 6 plus 2m. If this goes over here 18, 18 is equal to m times 2. So the value of mass of the second ball in b bit is equal to 9 kg per second. So there are two possible values of this mass. One value is equal to 1 kg, sorry, not second, I'm sorry, 1 kg, and the other value is equal to 9 kg over here. Two answers are possible. Let us see. Do we have these answers? Yes, we have both of them. So the answers over here are 1 kg and 9 kg, option A and option D. I hope this is clear till here to all of you. You see, whenever you take any question, try to concentrate on the critical points in the question. For example, he mentioned perfectly elastic direct central impact. Without that point, I could not have solved this particular question. Otherwise, he had to give me the value of coefficient of restitution E. Moving further to the next question. Now this again is particularly for mechanical people. This is from the concept of general plane motion. Very good question. Let me step aside, read this question. This should be easy for you actually. The question is saying, at a certain instant, the velocity of end A of a rigid bar. Generally when we say bar, it is by default rigid. Okay. Velocity at end A of a rigid bar AB is equal to 4 meter per second in the direction shown. So end A's velocity is 4 meter, direction also is shown to you. Knowing that the magnitude of velocity of end B is equal to 3 meter per second, the possible values of angular velocity of bar AB is or are equal to how many radian per second? Now how do we solve? This is very simple question. Believe me, it should not take more than 2 minutes to solve this question. Okay. Now, to answer this particular question, I should know, since the bar is rigid, therefore I can use multiple methods. One method is relative velocity method. Okay. Now relative velocity method says the relative velocity along the link must be equal to 0. Because if relative velocity exists along the link, then the link is supposed to experience some kind of deformation, which is not possible because the bar is rigid over here. So therefore I can say over here, this component of velocity along the link, it is equal to 4 cos 60, that is equal to, I am directly writing over here, 2 meter per second. Now, if this component is 2 meter per second, the component along the link at point B is also supposed to be equal to how much? 2 meter per second. 2 meter per second. Now, bear in mind the net magnitude of velocity over here is equal to 3. If 2 is done over here, okay, yaad kariye, 3 is the actual magnitude. Ab 3 is resultant of 2 plus something over here vectorially. So basically I can say 3 square is equal to 2 square plus the other velocity square, the other velocity perpendicular square, the perpendicular component square. Okay, na? So now that velocity is equal to how much? If you see from here, this goes over here, phi is equal to v perpendicular square. So v perpendicular at point B has to be equal to root phi. It has to be equal to root phi. Now again there are two possibilities over here. One possibility is, let us say A bit. V perpendicular is equal to root 5 over here. One possibility, let us say, is B bit over here. B bit. V perpendicular is equal to how much? Root 5 over here. Root 5 over here. I hope you are following this. In this particular case, my resultant velocity is A bit over here, which is velocity is equal to 3 meter per second. In this case, my velocity will be over here. B bit, let us say. Please excuse my handwriting. I am not explaining you over here. I am just taking some questions over here. Okay. So there are two possible directions of velocity over here. One possible direction is this way. One possible direction is this way. First quadrant and fourth quadrant over here. Now let us say A bit. If I take A bit over here, bear in mind this perpendicular component over here is equal to how much? V sin 60, that is equal to 2 root 3 bol lijiye. 2 root 3. Now A bit, I am solving for A bit. My velocity perpendicular over here is 2 root 3. My velocity perpendicular over here is root 5. You should know from vector concept, the value of VA vector is equal to VB vector plus velocity of A with respect to B vector. This is supposed to be equal to radius multiplied to omega. The radius is equal to 1 meter. This velocity over here is equal to, in A bit, 2 root 3 minus root 5. So I can say 2 root 3 minus root 5 is equal to 1 times omega. So the value of omega is equal to 2 root 3 minus root 5. 2 root 3 minus root 5. B bit, 2 root 3 will still be here, but root 5 is going downward now. So the relative velocity perpendicular is equal to 2 root 3 minus of minus root 5, which makes it 2 root 3 plus root 5. So B bit के लिए आप लिखेंगे 2 root 3 plus root 5 is equal to 1 times omega. So the value of omega in case 2 or B bit is equal to 2 root 3 plus root 5. This took some time for explaining, otherwise this would not take that much time. It is sort of an easy question actually. अब लगाइए values, put in these values in a calculator. If you do so, you are having 2 root 3 minus root 5 is one value, 1.228. I am having 1.23 over here if you see. This is in clockwise direction. Other case also is clockwise, both the cases are clockwise only. In B bit, I am having 5.7, option D. The correct answers over here are option A and option D. I hope these answers are clear to all of you. Okay. Moving further to the next question. This is a good question. This is particularly from civil engineering point of view. From the topic of vibrations for civil engineering, I am taking this particular question. The question is saying a small bob is attached to a cord of length 1.2 meter and is released from rest when angle theta A is equal to 5 degrees. You can see over here, theta A is equal to 5 degrees is said. Knowing that the value of small d is equal to 0.6 meter, there are 4 things over here. Option A, time required for bob to return to point A. So basically time period he is asking. So this time period is equal to how much he is asking. He has given 2 options over here for time period. The time period of oscillation, he has given 2 options for time period of oscillation. One is 1.88 seconds and the time period of oscillation according to the second case is 2.18 seconds. The amplitude theta c is equal to how much? He gave 2 options for theta c also, 7.07 degrees and 10 degrees. Let us see how to solve this particular question. Now if you think about the oscillation over here, in this oscillation I can break this oscillation down into 4 parts, 4 quarters. First quarter is going over here, second quarter is going over here, third quarter is coming back by theta c, fourth quarter is coming back by theta a. So now I can say half the time period corresponds to the length 1.2, half the time period corresponds to the length 1.2 minus d. D is 0.6. So half time period is for 1.2, half time period is for 0.6. If I remove 0.6, 0.6 only. So now I can say time period is equal to how much? 2 pi by omega होना चाहिए था. But this is equal to pi by omega 1 plus pi by omega 2. It is supposed to be 2 pi by omega, but we are taking half time period for first and half time period for second case. Therefore 2 pi by 2 times this thing, so pi by omega 1 plus pi by omega 2. This is equal to how much? Pi common to 1 by omega 1 plus 1 by omega 2. Now recall, what is the value of omega? Omega is equal to root over of g by L. So therefore 1 by omega is equal to root over of L by g. So this is pi root over of. In first case, the value of length is equal to 1.2 meter. G is, let us say, 9.81 plus root over of 0.6 upon 9.81. Let us calculate this thing. You please don't use these calculators for practice. You will not have these calculators in your examination. I'm getting the value of time period over here. The effective time period over here is equal to 1.8757 seconds. Let us see, do we have any option supporting this thing? .8757, 1.88 is fine. So option A is correct over here. So one option is option A over here, that is correct. Now amplitude theta c is equal to how much? How do I find out theta c? Now you see, you are actually having a case wherein there are two oscillations taking place. One is with a length equal to 1.2 meter, one is with a length equal to 0.6 meter, but the angular velocity at mean position for both cases is supposed to be same. Angular velocity at mean position for both cases is supposed to be same. So I can say over here, theta dot maximum, angular velocity is theta dot, no? Maximum in case 1 has to be equal to theta dot maximum in case 2. In case 2. Now what is the formula for theta dot maximum? It is equal to omega into theta maximum. Omega 1 theta 1 maximum has to be equal to omega 2 theta 2 maximum. Theta 2 maximum. Theta 2 maximum is basically the amplitude theta we want to find out. Theta 1 maximum we know is equal to 5 degrees. Omega 1 is equal to root over of g divided by length. Length in first case is 1.2 is equal to root over of g divided by length over here is equal to 0.6 theta 2 maximum. So this value over here, 1 second. Omega into the value over here is supposed to be equal to, 1 minute, I have made a mistake over here. Right. So theta 2 maximum is equal to how much over here? It is equal to 5 degrees divided by root 2. 1 second. This is given as 5 degrees now. So it is supposed to be equal to yes, this is supposed to be equal to if this comes over here, 5 degrees divided by root 2. 5 degrees divided by root 2. Okay. This is the value I am getting. Okay. Fine. 1 minute. Okay, this value if you compare, .53 I'm getting. 3.53 is not present over here, so neither one of them is the answer. Amplitude theta c now. Okay, let us move further. Let us take this particular question. The question over here is saying a rigid rod ABC in the form of a quarter circular arc of radius r is hinged at point C and is supported by a roller at point B. A vertical force P is applied at the end A of the bar. For the reaction at B and C to be equal in magnitude, the value of angle theta in degrees is equal to how much? Okay, this angle theta we have to identify. Now this question is from the concept of equilibrium. Now to find this out, I'm going to take this particular diagram and draw the free body diagram of this thing. This, let us say, is a quarter circular arc. This over here is a hinge over here. This is a point A I'm having. At this point A, I'm having a vertical force P acting. Okay. Let me extend over here 2 lines. This, let us say, is a center over here, which is point O. At this point, I'm having, let us say, roller support. I'm having a hinge support over here. I know the roller support reaction is supposed to be passing through point O. So therefore, my net reaction over here, this net reaction is supposed to be passing through point O. This let us call as reaction at point B. I can break this down into 2 components. One is horizontal at point B. One I can say is vertical at point B. I can say over here I'm having 2, let us say, horizontal at point C, and I can say vertical at point C. I want to find out this angle theta over here. I know this angle and this angle, both of them are same. That means if I find out the value of HB and VB, I'll get the value of theta. Theta is equal to tan inverse of VB upon HB over here. Now, how do I start? I'll first of all start with sigma fx equal to 0. Sigma fx equal to 0 says HB is equal to HC. I have an equation over here. HB is equal to HC. One equation is present. Now, one very important statement given in the question was the magnitude of reaction at point B and point C are equal. That means RB and net reaction over here, RC, net reaction over here, RC, both of them are equal. Okay, both of them are equal. If RB and RC are equal, HB and HC are equal, VB and VC also should be equal. So I can say over here, VB must be equal to VC. VB must be equal to VC. Now VB must be equal to VC implies over here, if I take sigma f y equal to 0, sigma fy equal to 0, I am having P minus VB minus VC. So P minus VB minus VC, I can say 2VB is equal to 0, which implies the value of VB over here has to be equal to how much? P by 2. I have identified the value of VB also. If I identify the value of VC, everything is done. HB, everything is done. To identify the value of HB, what I'll do? I'll take moment about point O is equal to 0. If I take moment about point O is equal to 0, mind you, RB net value is passing through O, VC is passing through O. So only P will create moment and HC will create moment. So let us say, if I take over here, summation of moment about point O is equal to 0. P is creating clockwise moment, so minus P times radius. HC was creating anti-clockwise moment, so plus HC times radius must be equal to 0. From here you get HC is equal to HB is equal to P. HC is equal to HB equal to P. Now you have VB value, you have HB value. Sometime back you saw the value of theta is equal to, you saw the value of theta is equal to tan inverse of VB upon HB. VB is equal to how much? P by 2. HB is equal to P. You are getting tan inverse of half. This is tan inverse of 0.5. So if you calculate tan inverse 0.5, it is 26.565. You can say 26 point, if you are rounding off, 57 degrees. The answer over here is 26.57 degrees. Now this was a question on the concept of equilibrium, numerical answer type question. Let us move further. The next question I am taking for mechanical people from the concept of trusses and frames. If you look at this particular question, the question is saying a pin joint truss has a pin support at A and a roller support at C. all members are made of same material and have the same cross section. Neglect self weight of the members due to the applied loading shown. The total number of zero force members is equal to how much? Very, very good question. Total number of zero force members. Now, if you remember regarding zero force members, we have discussed there are some rules for zero force members. The first standard rule we are having, if at all you are having a particular joint, if you are having a particular joint where you are having only two members and no other force present, and those two members are non-collinear, both the members are zero force members. For example, you can see over here, this particular joint is one such joint where you are having two members. First of all, every member has axial loading. Remember this thing, trusses mein, in trusses every member is only axially loaded. Okay? So now at this particular point, you are having two loadings only, one from here, one from here, non-collinear, guarantee both of them must be equal to zero force. Okay. Second standard rule we are having, if you are having a particular joint where you are having three members or three kind of loadings, of which two are collinear, third unknown loading is non-collinear, then the third unknown loading or third unknown member must be a zero force member. So that I'm not able to find over here, but let me take an example. If at all you are having over here T1, you are having over here T2, you are having over here T3, guarantee T3 has to be zero force member. What is the logic? Simple logic. If you take T1 and T2 as a particular axis and you take the perpendicular axis, summation of force in the perpendicular equal to 0, guarantee T3's perpendicular component 0, T3 itself is 0. Anyway, so now if I use these logics over here, this is a very good question. First of all, I get over here, these two members are zero force members. If these two members are zero force members, now concentrate, eliminate them and concentrate at joint C. If you concentrate at joint C, you are having a vertical reaction over here. You are having a loading in CF. These are two loadings. This is the only third loading, non-collinear loading over here. Only third loading, which is non-collinear loading over here. So this has followed this particular condition. This point C over here is this kind of point where two of them collinear, one non-collinear. This is this and this collinear, this is non-collinear. So therefore this is a zero force member. Now I have identified three over here, but let us further move and find out the value of RC. The reaction at point C is equal to how much? If I take the moment about point A is equal to 0, this P is creating a clockwise moment, this is creating anti-clockwise moment. Both of them are having same lever arm. So therefore RC has to be equal to 0. RC over here has to be equal to 0. If RC is equal to 0, you see both of them are equal also. If RC is equal to 0, this also should be equal to 0. So this is also a zero force member. If you eliminate these things, then come to this particular joint. This joint is now experiencing only two forces, both of them non-collinear forces. So both of them have to be zero force members. Both of them are zero force members. Okay. Now that we have arrived till here, ultimately my truss is something like this right now. Excuse my diagram. My truss is something like this right now. Okay. Now come to this particular joint. At this particular joint, this loading and this loading are collinear. He is the only loading non-collinear. So this and this both are equal and this is equal to 0. That means this member also is a zero force member. Only remaining members are BE and AE member. Both of them are non-zero force members. Okay, BE is going to experience a loading which is a compressive kind of, tensile kind of loading over here. And AB is also going to experience a loading over here, right? AB is going to experience a compressive P root 2. This will be P root 2 compressive. This will be P tensile. Rest of them are of 0. So now what do I have? 1, 2, 3, 4, 5, 6, 7. In total, I'm having 7 zero force members. He gave me 9-member truss, of which 7 members are zero force members. The answer over here is 7. The answer is 7 over here. I hope this is clear till here to all of you. This was a very good question on the concept of trusses and frames. Moving further. Now this question is particularly for mechanical people. I have taken this question from the concept of Newton's second law of motion and kinematics. This is a previous GATE question from XC paper. The question is saying a particle of mass 0.1 kg which is released from rest falls vertically downward under gravity in a fluid. The fluid offers a resistive force which is linearly proportional to the particle velocity with 0.1 Newton second per meter as a constant of proportionality. Something not exactly viscosity, something similar to viscosity, not exactly viscosity though. The uniform gravitational acceleration is 10 meter per second square throughout the trajectory of the particle. The magnitude of particle velocity in meter per second at time t equal to 1 second after the release is equal to how much? Round off to 2 decimal places. Let me explain what is happening over here. This question over here is saying you are having, let us say, a vertical channel filled with a particular viscous fluid. You are dropping a ball over here. This ball you are dropping, its mass is equal to 0.1 kg. 0.1 kg. The acceleration due to gravity over here is equal to 10 meter per second square. 10 meter per second square. You have dropped this particular ball now. After having dropped this particular ball, you are realizing that there is a resistance also over here. Okay, let us call that as drag force. The drag force over here is equal to 0.1 times velocity. 0.1 times velocity over here. The question is saying that the value of initial velocity is equal to 0. V is equal to how many meter per second at time t equal to 1 seconds. For this purpose, what I am going to do, let us see the free body diagram. Let us say the ball is somewhere over here. There is going to be mg acting over here. There is going to be fd acting over here. He has not given me anything regarding buoyancy force. I am neglecting buoyancy force over here. It's a particle mass anyway. Buoyancy force is not existent right now. This is what we are having right now. Now, this fd over here is going to be always less than mg until you reach the terminal velocity or settling velocity condition. Okay, so right now fd is less than mg, the velocity v is down over here, and the acceleration also is down over here. V is also down, acceleration also is down. Now I can write over here summation. I'm taking downward direction positive. I'm taking downward direction positive over here. I can write summation of force has to be equal to mass times acceleration. If I take downward as positive, mg minus fd, drag force, has to be equal to how much? It has to be equal to mass times acceleration. So 0.1 g is 10. Fd is equal to 0.1 v is equal to mass is equal to 0.1. I can write acceleration over here as dv by dt. I can cancel 0.1 throughout. If I cancel 0.1 throughout, I am having an equation which says that 10 minus v is equal to dv by dt. Go for variable separable method. Rest of it is mathematics now. dt is equal to dv upon 10 minus v. Integrate कीजिए both sides. You know, at time t equal to 0, velocity is equal to 0. At time t equal to 1, velocity is equal to v. So you have, this is now mathematics only. Very simple, that too. Now you can say over here, if you integrate left hand side, you will get 1. 1 is equal to integral dv upon 10 minus v is equal to ln of 10 minus v divided by minus 1. It is equal to ln of 10 minus v divided by minus 1. I'll put this minus 1 over here. Ranging from where to where? 0 to v. 0 to v. So now I'm going to have minus 1 is equal to ln of. If I put upper limit, I'm going to get 10 minus v. If I put lower limit, I'm going to get 10. So 10 minus v divided by 10. This is what I'm having. Put anti-log, so this becomes e power minus 1 is equal to so and so. So you're having 10 times e power minus 1 is equal to 10 minus v. So v is equal to 10 into 1 minus e power minus 1. This is the answer. The answer is 10 into 1 minus e power minus 1. I personally prefer to push calculations for the last step when it comes to these numerical answer type questions. I'm getting the answer as 6.3212. 2 decimal places, answer will be 6.3212. 32, let us say. Answer is 6.32 meter per second. This is worth 2 marks in your examination. It was having a concept of Newton's second law and kinematics with some basic integration. Okay? This should be very easy for you. Moving further to the next question. This again is Newton's second law. Let me take some other questions so that time we don't have. Let me take this question. The question over here is saying a 2 kg steel rod of length 0.6 meter is clamped on a table vertically at its lower end and is free to rotate in vertical plane. The upper end is pushed so that the rod falls under gravity. Ignoring the friction due to the clamping at the lower end, the speed of the free end of the rod when it passes through the lowest position is. Now these kind of questions, first of all, let us draw these questions and think about what method you are going to employ to answer these questions. The question says you are having a table over here. To this table, let us say over here, you are taking a particular rod. You are clamping this rod over here. This is stage 1. You are dropping this, you are gently pushing it. When you gently push it, this rod is moving and eventually you are observing this particular rod when it has come to this particular position. When it has come to this particular position. Okay, 1 second. What all things he gave regarding this rod? The rod is having a length of 0.6 meter, mass is 2 kg. You have to find out the velocity, free end velocity at the lowest position. So basically, if you get the value of omega, everything is done. Okay? So now I can say over here, this is stage 1 I am having, this is stage 2 I am having. If you think of using Newton's second law of motion method over here, it becomes very difficult. It is not practically easy for you to solve by Newton's second law method. The reason being, you see, you have to avoid Newton's second law whenever acceleration is a very complex variable. This is a case where acceleration is a complex variable. You see, every instant the acceleration is keeping on changing. So best method, employ the work energy theorem. We know by work energy theorem, change in energy is equal to how much? Work done minus losses. There is no work being done, there are no losses over here. That means energy in stage 1 has to be equal to energy in stage 2. Energy in stage 1 has to be equal to energy stage 2. Ab energy stage 1, let us do one thing. Let us take this as our reference datum. Now this length distance from its center to its center will be exactly equal to L, length of the rod. So now energy in stage 1 is only potential energy, that is equal to how much? It is equal to mgh or mgl in this particular case. In second case, since I have taken this as my reference datum, the only energy I am having is kinetic energy. And kinetic energy over here is equal to half of, because it is a rotation about this point, half of I about end omega square. Now what is the value of I about end for a rigid rod? It is equal to ml square by 3. याद होना चाहिए आपको. So this is equal to how much? mgl is equal to ml square by 3 into omega square. The value of omega over here is equal to how much? Root over of 3g by L. Omega over here I am getting is equal to root over of 3g by L. This is the value of omega I am having. Once I have identified the value of omega, I can say this end over here is having a velocity this way, because rotation is like this. The value of velocity over here is equal to how much? It is equal to r omega. From here the value of r is equal to L. So velocity of other end over here, free end over here, is equal to r omega. So L times this value, so it becomes root over of 3gl. That is what I am saying. Try to push calculation as late as possible. Now you do calculation. अब लगाइए. G value he gave 10 क्या? G value he gave 10. Okay, length is equal to 0.6. So this is going to become equal to root over of 3 times 6 is root over of, this is 3 root 2 basically. The value is 3 root 2. 3 root 2 will be equal to how much? 1.41 into 3 will be equal to 4.23. 4.23. The answer is 4.23 meter per second. I hope this is clear till here to all of you. Moving further to the next question. I'm not having much time. I'll take one question from rolling friction. Rolling friction is a sort of important concept for mechanical people. The question over here is saying a rigid circular disc of radius 0.2 meter and mass 10 kg rolls without slip on a ground at point A. Bear in mind it is rolling without slip. The coefficient of static friction mu, that is supposed to be mu over here. The coefficient of static friction mu between ground and disc is equal to 0.7. A torque T equal to 9 Newton meter acts on a disc as shown. Given acceleration due to gravity is equal to 10 meter per second square. Frictional force acting on the disc in integer is equal to how much? So he wants over here integer value of friction force acting on the disc. Very good question. अब important key points क्या क्या है यहाँ पे? First key point over here is rolling without slip. Okay. Now mind you, whenever rolling without slip is there, you are going to have static friction. You can't have kinetic friction. The coefficient of static friction is also important, 0.7. That is giving you limiting static friction value. And torque applied is equal to how much? 9 Newton meter. Acceleration due to gravity, this much. Radius 0.2, mass 10 kg. Mass 10 kg. Chalo. Now first thing I'm going to do is I'm going to find out my limiting static friction, which is equal to how much? Mu times normal, in this case mu times mg. Mu is equal to 0.7, mg is equal to 10 times 10, so this comes out to be 70. Now if I calculate, my answer should be at maximum 70 or less than 70. If it is more than 70, then this is not possible at all. This question itself is wrong. Because if it is more than 70, that means I am exceeding my Fs value, which is not possible. That means slip is taking place, kinetic friction should occur. Slip is taking place then. So now I have to check, the value should come out to be less than 70. 70 is not your answer. आपको check करना है अभी. You have to check now. It should be less than 70 or equal to 70. At worst case scenario, equal to 70. Now let us see. Over here, this is a disc I am having. If I draw my free body diagram, I am having over here mg coming down. I am having a torque applied over here which is equal to 9 Newton meter. I am having over here normal. Now think about it. For this body to roll without slip, I am thinking about how my acceleration is supposed to be. For this body to roll without slip, this body is supposed to accelerate forward. The only way it can accelerate forward is friction force is acting in the forward direction right now. This is friction force over here. This is friction force over here. Now I can say over here summation of fx is equal to ma. Summation of fx is equal to ma over here. That means friction force is equal to how much? Ma. One more thing, whenever rolling without slip is taking place, I have taught you this thing, the value of velocity is equal to r omega and acceleration is equal to r alpha. Okay, so bear in mind the value of alpha is equal to how much? A by r. This is true as long as we are having rolling without slip taking place. Next thing I can say, summation of moment about center is equal to I about center times alpha. अब क्या है summation of moment about center? I am taking clockwise positive. Let us say clockwise positive. Okay. Now summation of moment about center is equal to how much? Torque 9 Newton, clockwise है. So 9. Or let me avoid numbers now. Torque. F is creating anti-clockwise moment. So I can say over here minus F times R is equal to Ig, disc है ये, it is disc, therefore mr square by 2, alpha is equal to A by R. Alpha is equal to A by R. I can cancel off over here the value of 1r and 1r, and I can take this MA and I can equate it to F. So I'm having over here T minus FR is equal to how much? This MA has become equal to F, so FR by 2, which implies 3FR by 2 is equal to T, is equal to T. The value of F I am having now, the value of F is equal to how much? 2 times T divided by 3 times R, that is equal to, now T is given as 9, R is given as 0.2, so 2 times 9 divided by 3 times 0.2. So this is basically 90 by 3, 30. The value of friction is therefore equal to how much? 30 Newton. The answer is 30 Newton. You are getting exactly a numeric integer value. And you are seeing this value of friction is less than 70, I believe, for Fs. So therefore, you are within static condition, you are having this value. Therefore, if I want to complicate this question, I can create one more question below this. I can say, what is the maximum torque allowed? Ab maximum torque allowed ke andar this will become Fs and this will become T maximum. Fs is 70 over here. Accordingly, you can get over here the value 70 le lijiye aap. So this is going to be equal to if I take this as 70 over here, so 7 times 3 is equal to 21. One second. So answer of torque will be equal to 21 Newton meter. That is the maximum value. So I can create a multiple set question also. It will become very complex. In such a case, the maximum torque is equal to, the maximum torque is equal to 21 Newton meter is the maximum torque. That is when, if you go beyond 21 Newton meter, then slip is taking place. I hope these questions were clear. Okay. If you have any difficulties, you can contact us. I'm very happy to help you then. Okay? All the best to all of you.